Right, moving on to the second subtopic, which is on thermal expansion. So in this subtopic, you should be able to define what is the coefficient of linear area and volume thermal expansion, and lastly solve problems related to the thermal expansion of all three of this. So thermal expansion. So thermal expansion is defined as a change in dimensions of a body accompanying a change in temperature. So meaning that the change in dimensions is due to the change of temperature lah. Okay, so three types of thermal expansion are linear area, and volume. So in solid, all types of thermal expansion occurs, which is all three of these will occur for a solid object. Okay, but for liquid and gas, only volume expansion occurs, and then at the same temperature the gas expands greater than liquid and solid. Okay, so first one, coefficient of linear expansion, which is alpha. It is defined as a fractional increase in length, length of a solid per unit rise in temperature. So mathematically it can be written as shown here. So if the difference in temperature is negative, then the change in length will also be negative. So the length decreases. And vice versa. So the temperature change will be the same in both Kelvin and Celsius scales. The unit is either per degree Celsius or per Kelvin. And the length could be the length of a rod, ataupun the side of a square plate, ataupun the radius of a hole. Okay, so coefficient of area expansion pula, the symbol is beta, and then is defined as a fractional increase in area, in area of a solid surface per unit rise in temperature. So mathematically the only thing changes is the delta A. Instead of delta L, it becomes delta A, which is the change in area. Okay. So this is the same, and then for isotropic material, the area expansion is uniform in all direction. So we can create an equation that relates the alpha and beta, which is this equation. Okay, so beta is equal to 2 alpha. And then lastly, the coefficient of volume expansion, gamma, is defined as a fractional increase in volume. So this one is in volume. And then mathematically it can be written as this one. Instead of delta A or delta L, it is now delta V. Okay, so okay, I forgot to change this one because I just copy it, but I'll change it later for your notes. And then the relationship between alpha and gamma is this one shown here. Okay, so gamma is equal to 3 times alpha. Okay, and then lastly, thermal expansion of a liquid. So when the liquid of a vessel is heated, both liquid and vessel will expand in volume. Remember, gas and liquid will expand lah. So this expansion is called apparent expansion and always less than the true expansion of the liquid. So the coefficient of volume expansion is defined in the same way as the coefficient of volume, which is the one shown here. So the volume expansion of a liquid, whether true or apparent, depends on the change in density of the liquid. Okay, so the variation of liquid density can be related using this equation here, where rho is the final density and then rho naught is the initial density lah. So the thermal expansion of liquid depends only on the expansion of the container that it fills. Okay, so it depends on the container juga. So the liquid in a container will overflow or not when the temperature rises only depends on the liquid and not the volume of container. So when the temperature increases, both the liquid and container will expand. So if they were to expand by the same amount, there would be no overflow. Logically thinking, mestilah kan? So if this is your liquid, and then if both expands, so they will be expanding linearly lah, okay? So they will be expanding in the same way ataupun in the same amount. Okay, tapi if only one of them expand, for example, this container will not expand, only the liquid expand, so there will be an overflow lah. Okay, boleh faham kan? So okay, that explains the one here. So overflow volume is the amount of liquid expansion minus the amount of container expansion lah, which is the one shown here. Okay, So you will get into detail for this one in the next few examples. Right, so that is our final subtopic for chapter 12.